Hello students, welcome back. How are you all? I hope you're all fine. Okay, and today we are going to start a very new chapter, students. The name is surface area and volume. Now, you're very familiar with this word surface area and also the volume, but we will be having a brief discussion about that what is basically the surface area of anything or any object and what is the volume of it. Okay, so if I talk about the surface area of a thing or on a, or an object, then what will I do? What will I do if this is the object I'm having? Okay, so the surface area means all the area which is on the surface. That means all the surfaces that are exposed to the environment that we can see. We will calculate the area of this particular part only the outermost layer part. Okay, the complete layer. Okay, so this is about surface area, and this is in square units. Okay, we always have surface area in square units. And if we talk about this volume, then the space occupied by any object, let's suppose this object. Okay, this is basically a cuboid. So we will be having this unit in cube. So unit will be in cubes, like cubic meter. Okay, or in case of surface area, we can have meter square, centimeter square, like that. Okay, so we are having surface area and we are having volume. Surface area is actually basically the area of surface, okay, of an object, and volume is the space occupied by that particular object in space. Okay, like if I'm having here nothing, okay, and I'm putting this object on my hand. Now this complete area is covered by what? This. So this complete space is what? It's volume, right? Okay. So this is about surface area and volume, and we'll discuss about different surface areas and volume, like of cube, cuboid, cylinder, etc. Sphere. Okay, so why we are basically reading this? Why we are studying? What we are having to do with that surface area and volume of any shape? Because in general, we make use of things like we can use bullets, okay, and we can have a construction of some parts of particular let's suppose engine, or let's suppose we are making parts of any machine. So there are definite shapes and sizes of these parts. Okay, so these are needed to be calculated, and to in order to calculate these, what we are going to do, we just know about the shape, about the size, about the surface area of it, about the volume of it. Okay, and the related questions, how this is gonna be very helpful in our day-to-day life, in your home, if you construct anything. Okay, if you are doing a construction of your home, renovating your home, then the rates will be deciding according to all this chapter, surface area and volume, you will see. Okay, so this is about the surface area and volume. Now we are first discussing about surface area of a cuboid and a cube. So basically there is nothing major difference between cuboid and cube. Basically the cube is a specific kind of cuboid which is having all the dimension equal to each other, and that will be L equals to B equals to H equals to L, let's suppose A. Okay, so this is the basic difference between cuboid and cube. We are here going to talk about first cube, and I've told you that this is the classic example of a cuboid. Okay, so we are going to talk about first cuboid and then we'll talk about cube. Okay, so you can see three dimensions here, students, if you look closely. Like this is one dimension, this is one dimension. Let's suppose this is the height, and this is the long one. This is the what? Length, and this is the width. So we are having width, length and height, three dimensions of it, this cuboid. Okay, now let me discuss about the surface area. Now what is the surface area of cuboid? What is the surface area of cuboid? Surface area, all the areas of all the exposed surfaces. And what are the exposed surfaces? Let us count. 1, back 1, 2, here 3, 4, up 5 and down 6. So we are having six surfaces of this cuboid, right? Okay. So we are having 6 surfaces, and if you look how will a cuboid make, then you can just imagine that you're having a layer of something. So this is one surface, and you'll put another surface on it, another surface on it, and then another surface on it. It will give you eventually of a shape of cuboid, something just like your book. It is made up of page. Now consider a page as a surface. Okay, so one surface, another one over one another. Okay, so this continuous chain will give you some particular shape which is known as cuboid. Basically this is made up of rectangular surfaces. Rectangular surface is a must. Okay, so here you can say we are having a sheet of paper or a surface of something, and the surface of something, if we are overlapping the same rectangles one over the another, then we are going to have a cuboid. Okay, so basically the area of a rectangle is what? Length into width. Again, area of any rectangle. This is the rectangle. Okay, so area of rectangle is what? If this is width and this is length, then the area will be L multiplied by B. Okay, now we are having this as 1, and this is the height h, and this is the height h. So in order to have the volume of it, we'll be having L multiplied by B multiplied by h, but this is something we are going to study in the volume section. Talking about the surface area, how will you calculate the surface area? You have to calculate surface area of this and this and this and this and this and this. These 6 surfaces you'll be going to find out the surface area, and then you add them, sum them up, and you'll be getting the surface area of a cuboid. This is the procedure, and now let us follow this one by one. Okay, so if the surface area, that will be the surface area, complete surface here. Look, if this is the cuboid, okay, I've told you this is a cuboid, then this surface is what? Here. Basically, if you look closely, that will be your, this will be your what? It was looking like that, so this was the top. Okay, so this is the top, right? This is the top, and this surface is here, right? This is basically what? This is your, let's suppose, right surface, right hand side. Similarly, that will be your this side. Now the top is covered, this side covered, this side covered, now this one. Okay, so that will be, you may say that this side you'll be having RHS, and this side again LHS. So these 5 surfaces covered, 1, 2, 3, 4 and 5. Now the left one is this, so this is the bottom part. So basically this is the scenario here. I've told you that this is the what? This is the width and this is the length. That means this is the width and this is the length. Similarly, that will be length also. Okay, I can say this will be also the length. Here this is also the length. Okay, now these are length, okay, width, okay, this is what? Height. So when I am taking this surface or this surface or this surface or this surface, this dimension is common, which is height. So basically these dimensions are what? H. All heights. Okay, similarly this is also length, and with this length in the top and bottom, with the length we are having this width. Okay, so this is width. Okay, this is height, and again this is height. So this is how you will be looking at the dimensions. Now what I have told you, this is about the dimensions you are having, but what I have told you, to sum that all up, so basically if you calculate the surface area here, so the surface area, of cuboid will be basically what? Surface area of the first part here. Let's suppose this is first, this is second, this is third, this is fourth, this is fifth, and this is sixth. Okay, so in this case we are going to sum that up. Surface area 2, then surface area 3, then surface area 4, then surface area 5, and then 6th. Understood? Now we are going to have it one by one. The first one is this L, length multiplied by height. So first is length multiplied by height. Okay. The second one is length multiplied by width. The third one is length multiplied by height. The fourth one here is L and B, L multiplied by B. The fourth, then fifth one is height multiplied by width. And similarly the sixth one is also height multiplied by width, as you can see here. Okay, now that will be equals to LH and LH. So 2LH plus LB and LB. So 2LB, and the last one is HB plus HB. This is not hemoglobin, student. 2H. Okay, and when you will be taking out 2 common, you will be remaining with 2LB plus BH plus H. Okay, take common 2 here. So 2, this LB plus BH plus LH. So that is going to be your formula of what? Total surface area. This is what? Total surface area. Why I am telling you total surface area? It is whenever you are being used with this particular term surface area, you're going to make it assume that you're talking about the total surface area only. You're not talking about anything else. You are talking about the complete surface area. So if we are using the term surface area, that means you are using only total surface area as it. So is there any term other than surface area, total surface area? Yes, there are terms like lateral surface area, and we'll get to know that in 3 to 4 minutes. Okay, so this is about the surface area of cuboid. Are you done with it? Okay. Surface area of a cube. Okay, I've told you something, students, that what is the difference between cube and cuboid? Basically, cuboid becomes cube if length is equals to height is equals to width, and let's suppose it's equals to some dimension A. Okay, so basically L equals to B equals to H equals to A. We are checking 3 dimensions are equal to each other. Okay, so if this is something like that, that means that we are having here our formula. And what was the formula? The formula was of cuboid, surface area of cuboid was equals to 2 LB plus BH plus LH. Okay, this was the formula. Now can you put A equals to L and equals to B equals to H? Okay, so here it will be A square, again A square, again A square. That is going to be what? 2 multiplied by 3A square, that is equals to 6A square. So by that you can see this. Okay, and if you are taking a cube and having its dimension equals to A, okay, all the dimensions are A, length, width, height, all are same. So all are same. Now what I is saying that the surface area of one face is A multiplied by A is equals to A square. Similarly, this was the first one, this is the second surface, this is the third surface. This surface, it is something like this from the back, so that will be the fourth, this complete will be the fifth, and this will be the sixth surface. So total 6 surfaces. So total surface area will be 6 multiplied by A square, that is 6A square. Okay, this is how it's gonna be. Okay, and if you talk about the volume of it, so volume of cuboid, I've told you, is equals to what? L multiplied by B multiplied by H. So the volume of cube will be A cube. Okay, here. Now I was talking about another term other than the surface area, and that was the lateral surface area, guys. Okay, that is the lateral surface area. We get to know about that. Okay, so here the area of 4 faces, right? If this is your, let's suppose, cuboid, okay, this is your cuboid, the area of the 4 walls matter, that means this is the first one, this is the second one, okay, then the third one and the fourth one. That means what is excluded? Upper and lower surface is excluded. If I'm talking about this, if this is the height, okay, if this is the height, then I'm going to this is going to be left and this is going to be left. This surface and this surface is going to be left, and these 4 surfaces we are going to take. So the area of these 4 surfaces, these 4 walls basically, is known as the lateral surface area. Basically, if you are sitting in a room right now and it's like rectangle shaped, your room is rectangular shaped, so you can see this side, this side, this side and this side, and you're having 4 walls. Okay, so if you are leaving the floor, okay, leave it. If you are leaving the ceiling, okay, leave the ceiling also. So without ceiling and without the floor, you will be having these 4 walls around you, and so the area of these 4 walls will be what? The lateral surface area. Okay, so the area of 4 faces is called lateral surface area of the cuboid. Lateral surface or area of a cuboid of length L is going to be, and width B and height H is going to be what? L plus B multiplied by H. Okay, and multiply it by 2. So this is 2 L plus B. This is not I, student, this is L. Okay, 2 LH plus 2 LHB, or you can just say that 2 L plus B multiplied by H. We use this often. Okay, so if we are going to see how is the thing going to be, how we are going to have the surface areas of these four walls. I have told you this is the height and this is the breadth and this is the length. Now talking about this surface, length and height. If this is length and this is height, similarly that will go with that. So length and height. Similarly, if I talk about this here, this is what, width, and this is height. So b multiplied by h and again b multiplied by h. So we are going to have 2 LH plus 2 BH. We can take 2 common. So L plus B and H is also common here. So 2L plus B H. This is the formula we are reading in this. Understood now? Any confusion about that? I hope you are not having any confusion. The same formula we can take. This is for the cuboid. So what for cube? For cube, just put L equals to B equals to H equals to A. So 2A plus A multiply by again A. So that will be 2 multiply by 2A multiply by A. Okay, that is going to be 4A square. Okay, so lateral surface area for cube is equals to 4A square if the A is the side of the cube. Understood this thing also? Understood it well? Okay. Now, enough about the understanding. We are going to solve the question here. Now, students, take a look. Hamid has built a cubical water tank. He has built a cubical water tank with lid for his house. So, he's going to be having a cubical water tank, and okay, this is also going to be covered. And this cubical tank, he has to cover with it's having age 1.5 meter. So each is what? 1.5 meter. Here also we are having 1.5 meter because it's a cuboid, right? So 1.5 meter. Understood? Now he gets the outer surface of the tank excluding the base. Now he is taking all the surfaces, but we are going to have here one surface also, na, this surface. Okay, this surface we are going to have. Right. So this surface is excluded. This surface is excluded. Okay, now it's taking that he gets the outer surface of the tank excluded the base covered with square tiles. Now here we are using the square tiles represented here like this. Find how much he would spend for the tiles, rupees 360 per dozen. 360 per dozen, that means for each bunch of 12 tiles is gonna spend 360 tiles. Okay, 360 rupees. He's going to spend 360 rupees for every 12 tiles. So how many tiles he will be using? First we have to find it. Okay, after finding that these particular amount or these particular number of tiles we are going to use, we are going to multiply it with the price. Okay, after multiplication we will be getting the cost. Before that we are going to find out the number. How you will be getting the number? This is the total surface area of 5 faces. This portion, this portion, this portion, this portion and this portion. These 5 portions we have to take. We have to find out the surface area of them. First thing. Then what is second thing? In the second thing we are going to find out the surface area of each tile, right? You're getting the surface area of each tile. You're getting the complete surface area. You will be dividing the area of each tile with the total surface area of these 5 surfaces, and then you will be getting the number of tile. The number of tile you will be getting, so you can calculate cost of each tile and you can then multiply it to the number of tile you're getting. So you'll be getting the expenditure of it. Okay. Here, Hamid has built a cubical water tank. So, okay. Surface area of cubical water tank. What will it be? Excluding base. We'll be having 5 surfaces. Each surface of cuboid will cube will be having this A multiply by this A. That is 1.5 meter multiply by 1.5 meter. Okay. So let's have the given things also here. Given age of tank equals to 1.5 meter is equals to 150 centimeters. Why I am taking 150 centimeters, I will let you know. Okay, equals to A, right? Okay. So excluding the base, that will be 5A square because we are taking 5 surfaces. Now 5 multiply by 150 multiply by 150, and what will be the unit, students? Simply centimeter square. Now this is the surface area of cubical water tank. Now surface area of each tile. Surface area of each tile. What is going to be? Surface area of each tile is square tiles of size 25. So basically you can say that age of tile equals to 25 centimeter. I have taken this 150 centimeter because of this given unit, centimeters. Okay. So surface area of each tile will be what? 25 centimeter multiplied by 25 centimeter, and the unit will be centimeter square or square centimeter. Okay. So number of tiles will be equals to surface area of cubical tank divided by surface area of cubical tank divided by surface area of each tile. Understood? Now put the values here. 5 multiplied by 150 multiplied by 150. You can having here 25 multiplied by 25, and that will be the outcome will be a particular number. Okay. So this is 25. Okay. 6 times. Similarly 6 times. 5 multiplied by 6 multiplied by 6. 30 multiplied by 6 is equals to 180. So the number of tile is equals to 180. This is clear to you till here? 180. That means total number of tiles equals to 180. Okay. Now given rate of 12 tiles equals to, or where was the rate here? 360 rupees. Okay. So cost of each tile will be equals to 360 by 12 simply. And if it is so, then the cost of what we are requiring, 180 tiles. 180 tiles will be equals to 360 multiplied by 12 multiplied by, so divided by 12 multiplied by 180. 3 times 30. So you can just calculate here 00, 4 and 5. So basically he'll be spending 5,400 rupees to in order to get these tile done for this cubicle tank. So this is about today's students. This is about today's session in which we have talked about the surface area of cube and cuboid, and also the lateral surface area of cube and cuboid, and we have done successfully a very good question here. Okay, and I was telling you in the very first session, in the very first 5 minutes, that why it is important to understand or to study these kind of things like surface area and volume of objects. Why we are studying this? This is because we are studying it. Because if you are having, if you are going to have some work regarding the construction or any daily life thing, you are going to need this particular calculation. This is how you are going to pay your workers in future. Okay, so students, take a good look of the complete lecture again, summarize it, memorize it, memorize the formula, understand the concept, and we are going to meet in the very next lecture of ours with the new, I guess, volume of cube and cuboid, and we'll be then talking about also the sphere. Okay, so it will be interesting. Okay, take care, take good care of the students. Bye bye.